A warm welcome to all our TVET lecturers. I'm Prashant Ramdas from Macmillan, and today I will tell you about NQF Level 4 of the exciting new NCV course called IT and Computer Science with specialization in programming and robotics. The course was launched at NQF Level 2 in January 2023. In January 2025, the Level 4 subjects for this NCV course begin. The three subjects at this level are Electronics and Digital Concepts for Robotics, Robotics and Industrial Automation, and Technical Programming, which is a subject I'm presenting in this video. You will need the new textbooks to teach the correct content and prepare students for exams. The logo, New Curriculum 2025, tells you that this is the correct book. Later, I will show you why our DHET approved TVET First Students Book and Lecturer's Guide are your first choice for easily teaching this brand new curriculum. Now let's concentrate on getting to know the curriculum.
What is the aim of technical programming?
The aim of this subject is to give the students a solid foundation in logical thinking and problem solving so that they can develop stepwise coding solutions.
How will technical programming achieve this aim?
Students learn about the integrated hardware and software components of computer systems and how to use these components to solve everyday problems. Technical programming leans towards the design and creation of programs that enable physical computing. Physical computing involves interactive systems that can sense and respond to the world around them. In Level 4, students build on the practical and cognitive skills they develop in Level 2 and 3.
Why is it important to teach programming?
Students who learn programming become skilled in problem solving, design, and critical thinking. They learn the value of breaking a large problem into smaller sub-problems, and they learn how to apply solutions they have learned previously to solve new problems.
What should be taught when we teach programming?
The field of programming rests on two kinds of knowledge: program generation and program comprehension. Program generation requires the student to analyze a problem, produce a suitable algorithm, and then translate the algorithm into a program code. For program comprehension, the student must analyze existing programs to show that they understand how the program works and how the program will respond, with output based on the input provided.
How is this knowledge structured in the syllabus?
Topic 1 is computer hardware and software. It offers students a solid understanding of the fundamentals of computer systems, including memory and storage. Students learn that application software can enhance productivity, creativity, and problem solving, while system software maintains and optimizes computer performance. The core of a computer system is the operating system, which manages resources and serves as a platform for both system and application software. Topic 2 is about problem solving in computer programming. Building on levels 2 and 3, students now explore and create algorithms in the form of an IPO chart or flowchart that include various constructs, for example, determining the smallest and the largest value of more than two values, swapping values, and converting a decimal number into binary and vice versa. Topic 3 is called Concepts of Programming for Single Board Microprocessors or Microcontrollers. Here, students learn about the ARM architecture and Linux remote administration, including VNC and SSH protocols. They will also learn about Linux remote file editing using the Nano editor. Topic 4 covers programming tools and utilities. Students learn to install and use Git, the most widely used version control system, or VCS, in industry for source code management. They will then install and configure Python IDE on a desktop PC and create and save a new Python project using the IDE. Topics 5 to 12 fall under the heading Solution Development. They are grouped together as Solutions Development and incorporate the introduction of high-level programming languages. At Level 2, students worked with the Python programming language. At Level 3, students work with the C and C++ programming languages. For Level 4, students focus on Python. Topic 5 is a recap of Python as a programming language from Level 2. Level 4 focuses on developing code-based solutions using Python. For Topic 6, students must review generic concepts from Levels 2 and 3, as all code constructs and concepts covered in Level 2 are applicable to Level 4. All programming concepts learned in Level 3 also apply for Level 4. Students must consolidate their knowledge of things like data types, arithmetic operations, escape characters, and new lines and string method operation, amongst others. They complete integrated exercises to ensure that they reinforce the concepts they have mastered. Topic 7 covers interactive input, constants, mathematical functions, and errors. After reviewing concepts from Levels 2 and 3, students will work on basic file input and math library functions and strings. Topic 8 relates to selection control structures, including problem solving and selection statements. Topic 9 covers repetition control structures, including nested loops. Topic 10 covers modularization and functions, and students will learn about advanced Python functions and function parameters, as well as random numbers. In Topic 11, which is called arrays and lists, students begin with a basic Python list before progressing to advanced Python lists, followed by Python dictionary. Topic 12, called Concepts of Object Orientation, unpacks object-oriented programming, or OOP. Students learn how to incorporate a user-defined class as part of a code-based solution.
What are the guidelines for teaching time?
This subject is offered full-time over 2 semesters spanning 24 weeks, excluding assessment. This is equivalent to 2 double periods of about 1 hour 50 minutes plus 1 single period of approximately 50 minutes for each of the 24 weeks. This amounts to about 4.5 hours per week, or 56 hours. The 56 hours are broken down as follows. 36 hours are instructor-led contact hours, which also include practical sessions, and 18 hours are instructor-led contact hours dedicated to practical tutorials on computers. In addition, a further 10 hours per term, equivalent to about 1.5 hours per week, are required for students to practice on their own to reinforce practical skills. These 10 hours should be accommodated in labs which the college provides for students to use.
Do I need any extra resources to teach programming?
You will need the resources that the curriculum requires for all 3 levels. These include a fully equipped computer laboratory with mid-range networked computers, a high-quality printer, and internet access. You will also need robotics kits and electronic equipment.
How is the course assessed?
The curriculum will be assessed through 2 components: an internal assessment of 50% made up of only the ICAS, and an external assessment of 50% made up of the ISAT, which counts 15%, and the external examination, which counts 35%. The task quantity weighting of ICAS is made up as follows. There are 2 tests that count 10% each, making up 20% in total. There are 2 practical assessments of 25% each, making up 50% in total. And the last 30% is made up by the internal examination. Now let's look at the external assessment weighting. The tables explain both Paper 1, which is theory-based, and Paper 2, which is practical. Please note that this table is from the curriculum and refers to 11 topics, but there are 12 topics.
How can TVET FIRST support lecturers and students?
For a demanding subject like this one, TVET FIRST is an excellent choice. The authors of our Technical Programming NQF Level 4 Students Book are experienced TVET lecturers and national markers. They are also provincial and national world skills experts in computing. The TVET FIRST Students Book covers the 2025 curriculum completely and prepares students to succeed in their exams. Clear explanations guide students through the curriculum. Plenty of full-color screenshots, photographs, and diagrams support the text and make the learning experience fun and interesting. The book uses a step-by-step approach to teach problem solving. The student's book includes varied activities to help students consolidate their knowledge through practice. Summaries and exam-type summative assessments at the end of each module are excellent tools for students to revise and prepare for exams.
How does TVET FIRST support lecturers?
TVET FIRST has a full lecturer's pack to make lecturers' lives much easier. The pack includes the lecturer's guide and a USB. You can plug the USB into your computer to find year planning documents, study notes for students, and PowerPoint slide presentations for all the topics in the student's book. The lecturer's guide has information and resources for lecturers including comprehensive answers to all activities, links to online materials, photocopyable lesson plan templates, and a 40-week teaching plan. TVET FIRST textbooks are approved by the DHET and trusted by lecturers. For the best results, trust TVET FIRST.